Hello viewers, welcome to our channel Career Prep. In this video, we'll learn a few basic concepts about syllogism and how to draw Venn diagrams for the different types of statements. Questions based on syllogism are one of the most frequently asked questions in the reasoning ability section of almost all government exams, bank exams, insurance, railways, campus exams, etc. Syllogism questions require deductive reasoning to arrive at some conclusions from the given statements. It's important that you get an understanding of how to solve these questions without getting confused. This is one of the topics where marks can be scored easily if practiced well. In this series of videos on syllogism, you'll learn how to solve the questions. Each question is solved with a clear and easy explanation to help you in understanding the concept. So please do watch all these videos. Before we start, please subscribe to our channel. Also press the bell icon to get notification as soon as we post a new video. So let's start. So first let's understand what is syllogism. The word syllogism means inference or deduction. Syllogism is defined as a process of finding a conclusion from the given statements. It is an art of reasoning in which the conclusion establishes a relation between the statements. You have to take the given statements to be true even if they are at variance from established facts. In syllogism questions, you will be given a few statements and a few conclusions. You have to find out which of the given conclusions follow logically from the given statements. In syllogism questions, you will have statements and conclusions as well as options. Based on the conclusions drawn from the given statements, you have to select the correct option. Now an example of a syllogism question looks like this. You will be given directions, statements, conclusions and options. First, let's look what's given in the directions. In the following question, two statements are given followed by two conclusions. You have to study the two statements and then decide which of the conclusions follow from the statements. Mark the right answer from options 1, 2, 3, 4 and 5. So that is the directions. So here in the syllogism question, in this syllogism question, you're given two statements followed by two conclusions. Now, based on these two statements, you have to find out whether conclusion 1 follows or conclusion 2 follows. Now, after deciding which of the conclusions follow from the given statements, select the right answer from the given options. Now to solve a syllogism questions, the easiest way is to draw a Venn diagram for the given statements, and based on the Venn diagram, decide which of the conclusions follow. Then mark the right answer from these options. Let's understand what is Venn diagram. Now, syllogism questions can be solved by drawing Venn diagrams representing the statements. So, what is a Venn diagram in syllogism? A Venn diagram is an illustration that uses circles to show the relationships among the elements of the statements. So a Venn diagram is nothing but a diagram that uses circles, and these circles show the relationship between the elements of the statements. A Venn diagram uses circles that either overlap or don't overlap. Elements that have something in common are shown as overlapping circles, while elements that have nothing in common between them and are distinct stand alone and they don't overlap. Before we learn how to draw Venn diagrams for different types of statements given in syllogism questions, let's understand a few basic concepts like types of quantifiers, types of statements, and types of conclusions. What is a quantifier? A quantifier is essentially used to express the quantity of an element in the set. Now let's understand the different types of quantifiers used in syllogism. The main quantifiers used in syllogism are all, no, some, and some not. Let's learn more about these quantifiers. First, let's learn about the quantifier all. The term all refers to all the objects in the given set. Each, every, any, or 100% are equivalent to all. That is, all these words mean all. For example, all A are B means all the elements in the set A are B. 100% A are B means all A are B. That is, all the elements in the set A are B. Let's learn about the quantifier no. The term no refers to all the objects in the given set. No one, none, never, not a single, or 0% are all equivalent to the quantifier no. That is, all these words mean no. For example, no A is B. This means that each and every element in A is not a part of B. Similarly, 0% A is B also means no A is B. That is, each and every element in A is not a part of B. Let's move on to the quantifier sum. The term sum refers to a certain number of objects in the set. A few, most, mostly, many, almost, or at least some are equivalent to some. This means that all these words mean sum. Now we need to understand the range of the quantifier sum. Sum is a very unique quantifier. Its range starts from 1 to all. For example, some A's are B. This means that 1A is B, or it can mean that 10 A's are B, or 50 A's are B, or 70 A's are B. This range can go up to all A's are B. So the range of the quantifier sum starts from 1 to all. Similarly, if you use any of these qualifiers, it also means sum. For example, a few A's are B means that some A's are B. Remember that the range of the quantifier sum is from 1 to all. Let's move on to the quantifier sum not. Words like not all and all not are equivalent to some not. For example, some A are not B. This means that some elements of set A are not B. Let's now learn about the different types of statements. The different types of statements in syllogism are positive statements and negative statements. The quantifiers used in positive statements are some and all. For example, some cats are dogs. All cats are dogs. Now these are positive statements. Quantifiers used in negative statements are some not and no. For example, some cats are not dogs. No cats are dogs. These are negative statements. Let's now learn about the types of conclusions in syllogism. In syllogism, conclusions are of two types: definite conclusions and possible conclusions. Definite conclusions are those conclusions which are definitely true from the given statements. In other words, these conclusions have to or must follow from the logic defined in the statements. Possible conclusions. Possible conclusions are those conclusions which are not definitely true, but they may or may not be true. Let's now understand the meaning of definite conclusions and possible conclusions with an example. Look at this example. The given statements are some A are B, no B are C. So first let's draw a Venn diagram for these statements. Now you know that Venn diagrams are drawn using circles. So we have to draw circles for A, B and C. Now first look at this statement some A are B. This statement indicates that some elements of A are contained in B. This means that there has to be a partial overlap of circle A with circle B. Look at this statement, no B are C. This statement means that no element of B can have a relation with C. So draw circle C and then draw a line with a cross between circle B and circle C to indicate that no B can have a relation with C. That is, no B are C. Now this is the basic Venn diagram for the given statements. Now from this Venn diagram, let's understand the meaning of definite conclusions and possible conclusions. Now from this Venn diagram, it's clear that this portion of A is contained within B, which means some A are B. Also, this portion of B is contained within A. This means some B are A. Also, clearly you can see that there can be no relation between B and C. So, no B are C. Also, there can be no relation between C and B. So, no C are B. Also, you can see that this portion of A is inside B, and since B cannot have any relation with C, this means that this portion of A also cannot have any relation with C. This means some A are not C. So these conclusions, some A are B, some B are A, no B are C, no C are B, some A are not C, are all definite conclusions which follow from the logic defined in the statements. Now let's try to understand what are possible conclusions. Now when you look at this basic Venn diagram, it's clear that C cannot have any relation with B. Also, C cannot have any relation with this part of A because this part of A is inside B. But there is a possibility of C having a relation with this part of A. This is the uncertain portion of A. So C can have a relation with this part of A because there is no restriction between C and this part of A. Now, one of the ways in which C can have a relation with this part of A is shown in this diagram. So, C can have a partial overlap with this portion of A. Now, as you can see here, clearly the statements are not violated. Here also you can see that some A are B. Also no B are C. So the statements are not contradicted. But still C can have a relationship with this portion of A because there is no restriction between C and this portion of A. Now, from this Venn diagram, it is clear that some C being A is a possibility. Also, some A being C is a possibility. So, these conclusions, some C being A is a possibility and some A being C is a possibility, are possible conclusions. Hope you have understood the meaning of definite conclusions and possible conclusions from this example. Let's now learn how to draw Venn diagrams for different types of statements. First, let's learn how to draw a Venn diagram for the statement sum A or B. Now, sum A or B means some elements of A are contained within B. Now you know that Venn diagrams are drawn using circles. So you have to draw a circle for A and a circle for B. Now to indicate that some elements of A are contained within B, there has to be a partial overlap of circle A with circle B. So this is the Venn diagram for the statement sum A or B. Here clearly you can see that this portion of A is contained within B. This means this portion of A is B, that is sum A or B. So this is the Venn diagram for the statement sum A or B. Now whenever you are asked to draw a Venn diagram for statements like sum A or B, this is the Venn diagram that you should draw. Now as you can see in this Venn diagram, this is the area where both the circles overlap partially, and in this area you will find that there are elements of both A and B. Now that you have drawn the Venn diagram for the statement sum A or B, let's find out what definite conclusions and what possible conclusions can be arrived at using this Venn diagram. First, let's concentrate on definite conclusions. Now, as you can see in this Venn diagram, this portion of A is contained within B. This means this portion of A is B, that is sum A or B. So, sum A or B is a definite conclusion. Also, you can see here that this portion of B is contained within A. This means this portion of B is A, that is sum B or A. So sum B or A is also a definite conclusion. Now let's move on to possible conclusions. Now as you can see in this Venn diagram, this portion of A is contained within B. but you do not know anything about this portion of A. This portion of A is the uncertain portion of A and does not indicate anything about whether this portion of A can be contained within B or not. So this gives rise to two possibilities. In the first case, this portion of A cannot be contained within B. This means this portion of A cannot be B. So this means that some A or not B is a possibility. In the second case, this portion of A can be contained within B. Now we note that already this portion of A is contained within B. Now if this portion of A also is contained within B, it means that all of A can be contained within B. This means all of A can be B. So all A or B is a possibility. Now similarly, this portion of B is contained within A, but we do not know anything about this portion of B, which is the uncertain portion of B. Now this uncertain portion of B does not indicate anything about whether this portion of B can be contained within A or not. This gives rise to two possibilities. In the first case, this portion of B cannot be contained within A. Then this portion of B is not A. This means some B or not A is a possibility. In the second case, this portion of B can be contained within A. Now we already know that this portion of B is contained within A. Now if there is a possibility of this portion of B also to be contained within A, then it means that all of B can be contained within A. This means all of B can be A. So all B or A is a possibility. So the definite conclusions from this Venn diagram are some A are B and some B are A. The possible conclusions arrived at from this Venn diagram are some A or not B is a possibility, all A or B is a possibility, some B or not A is a possibility, all B or A is a possibility. Hope you have understood how to draw a Venn diagram for statements like some A or B, and also how to arrive at the definite conclusions and possible conclusions from the Venn diagram for the statements some A or B. Let's now learn how to draw a Venn diagram for the statement all A are B. Now you know that Venn diagrams are drawn using circles. So here you have to draw a circle for A and a circle for B. Now the statement all A are B indicates that all the elements of A are contained within B. So this means that circle A has to be completely within circle B. So this is how the Venn diagram for all A or B should be drawn. As you can see here, circle A is completely within circle B. This indicates that all A are B. Now here, a circle A is the smaller uh, circle and circle B is the largest circle. Here B has at least one element more than A. Now there is another way of representing all A or B. Uh, Here B has at least one element more than A. But supposing there is an equal number of A and B, then in the Venn diagram you will have only one circle which will represent both A and B. So here also you can see that all the elements of A are contained within B, that is all A are B. So these are the two ways of drawing a Venn diagram for statements like all A are B. But this type of Venn diagram is used only in a few syllogism problems. This is the most common way of representing all A are B. So whenever you have to draw a Venn diagram for statements like all A are B, this is the Venn diagram that you should be drawing. Now that you have drawn a Venn diagram for the statement all A are B, let's see what definite conclusions and what possible conclusions can be arrived at using this Venn diagram. First, let's concentrate on definite conclusions. Now, as you can see in this Venn diagram, all elements of A are contained within B. So, all A are B is a definite conclusion. Now, since all A is inside B, it obviously means that some A also will be inside B. So, some A or B is also a definite conclusion. Now, as you can see here, this part of B is nothing but A. So, some B or A is also a definite conclusion. Now, let's move on to possible conclusions. Now, as seen in this Venn diagram, it's clear that this part of B is nothing but A. But we have no idea about this part of B. This uncertain portion of B may be contained within A or may not be contained within A. This gives rise to two possible conclusions. In the first case, there is a possibility of this portion of B not to be a part of A. This gives rise to the possible conclusion some B are not A is a possibility. In the second case, this portion of B may be contained within A. There's a possibility of this portion of B to be contained within A. Now we know that already this part of B is nothing but A. So if this portion of B also is contained within A, this means that all of B is contained within A. So this gives rise to the possible conclusion all B or A is a possibility. So now you have the definite conclusions all A are B, some A are B and some B are A. Also you have the possible conclusions from this Venn diagram that some B are not A is a possibility and all B are A is a possibility. Now let's learn how to draw a Venn diagram for the statement no A is B. Now as you know, Venn diagrams are drawn using circles. So here you have to draw a circle for A and a circle for B. Now the statement no A is B indicates that no element of A can be contained in B. That is, no element of A can have any relation with B. So circle A and circle B have to be distinct and separate. They cannot intersect. So this is how you draw a Venn diagram for the statement no A is B. Here circle A and circle B are distinct and they cannot intersect. Now you can draw a line between the circles A and B and mark a cross to show that circles A and B cannot intersect. They have to be distinct. So whenever you have to draw a Venn diagram for statements like no A is B, this is the Venn diagram that you should be drawing. Now that you have drawn the Venn diagram for the statement no A is B, let's find out what definite conclusions and what possible conclusions can be arrived at using this Venn diagram. Now, as you can see here in this Venn diagram, no element of A is connected with B. So, A cannot be connected with B. So, no A is B is a definite conclusion. Also, you can see here that no element of B can be connected with A. So, no B is A is a definite conclusion. Now that you know no A is B, it obviously means that some A also is not B. So, some A or not B is a definite conclusion. Now that you know no B is A, it obviously means that some B also cannot be connected with A. So, some B or not A is also a definite conclusion. Now, let's move on to possible conclusions. Now, there are no possible conclusions because it's very clear that A and B cannot intersect. So, there is absolutely no way you can draw a possible diagram to um, show that A and B can intersect. So clearly here there are no possible conclusions. There are only definite conclusions. No A is B, no B is A, some A are not B, some B are not A. These are the definite conclusions. Let's now learn how to draw a Venn diagram for the statement some A are not B. You know that Venn diagrams are drawn using circles. So here you have to draw a circle for A and a circle for B. Now the statement some A are not B means some elements of A are not contained within B. Now let's see how to represent this in the form of a Venn diagram. So first draw circle A, then draw circle B. Now to indicate that some elements of A are not B, shade this small part of A and then draw a line with a cross from this shaded portion of A to B to indicate that this part of A is not B. So this means that some A are not B. So this is the Venn diagram for the statement some A are not B. So whenever you have to draw a Venn diagram for statements like some A or not B, this is the Venn diagram that you should be drawing. Now let's see what definite conclusions and what possible conclusions can be arrived at using this Venn diagrams. Now first let's concentrate on definite conclusion. As you can see in this Venn diagram, this part of A is definitely not contained within B. This part of A is not B. So some A are not B is a definite conclusion. Now let's move on to possible conclusions. Now this Venn diagram is the basic diagram for statements like some A are not B. But this basic diagram is not the only way of showing some A are not B. There are other possible ways of drawing a Venn diagram to show some A are not B. These diagrams are called possible diagrams. So these are other ways of showing some A or not B. These diagrams are called possible diagrams. One thing you have to remember while drawing possible diagrams is that you have to be absolutely sure of not violating the given statements. The possibility diagrams clearly show us what possible conclusions can be arrived at for the given statement. Now let's use these possible diagrams and see what possible conclusions can be arrived at. Now first let's see how these possible diagrams have been drawn. Now as you can see in this basic diagram, circle B cannot have any relation with this part of A, but B can have a relation with this portion of A. Now, there are two ways in which B can have a relation with this portion of A. There can be a partial overlap of B with A as seen in the possible diagram 1, or B can be completely within this portion of A as seen in possible diagram 2. Now in both these possible diagrams you can see that the statement sum A or not B is not violated. This part of A is still not B. Also here you can see that this part of A is still not B. Now there's another way of representing sum A or not B. Here you draw circle A and circle B separately and then draw a line with a cross between A and B to indicate that no A is B. That is, all the elements of A are not B. So if all the elements of A are not B, then definitely some elements of A are not B. That is, some A are not B. So this is also one way of representing sum A or not B. Now let's see what all possible conclusions can be arrived at using these possible diagrams. Now as you can see in possible diagram 1, this portion of A is contained within B. So sum A or B is a possibility. Also you can see here that this portion of B is contained within A. So sum B or A is a possibility. Now as seen in possible diagram 2, a circle B is within this portion of A. So all of B is within A. So all B being A is a possibility. Now let's move on to possible diagram 3. You can see here that no A is B. So no A is B is a possibility. Also no B is A. So no B is A is a possibility. Now if no B is A, it obviously means that some B also is not A. So some B or not A is a possibility. So sum A or not B is a definite conclusion, and all these are possible conclusions for the statement sum A or not B. Now whenever you have to draw a Venn diagram for statements like sum A or not B, this is the basic diagram that you should be drawing. Remember that this is the diagram that you should be drawing for statements like sum A or not B. Let's now learn about complementary pairs. A complementary pair is one in which one conclusion is positive and the other is negative. Always check for complementary pairs when the conclusions follow these conditions. Both the conclusions should be false. Both the elements of the conclusion are the same, that is, the subject and the predicate of the conclusions are the same. Now there are three types of complementary pairs in syllogism: some and no type, some and some not type, and all and some not type. Sum and no type. Example, sum A are B, no A is B. This is a complementary pair. As you can see here, this is positive and this is negative, and the subject and predicate in both are the same. That is, the subject and predicate are A and B in both these cases. Sum and sum not type. Example, sum A are B, sum A are not B. These are complementary pairs because this one is positive and this is negative. Also, both the subject and the predicate in these two are the same. That is, it is A and B here and it is A and B here also. All and some not type. Example, all A is B and some A are not B. These two are also complementary pairs because this one is positive and this one is negative. Also, the subject and predicate of these two is the same. That is, subject and predicate is A and B here. Here also it is A and B. Let's now learn how to identify an either or conclusion. You have to check for either or conclusion when the conclusions follow these conditions. Both the conclusions should be false. One conclusion should be positive and the other conclusion should be negative. Both the elements of the conclusion, that is, the subject and the predicate of the conclusion, should be the same. Both the conclusions should form a complementary pair. That is, they should be of the type some not, or some no, or all some not. Only when the conclusions follow all these conditions, then either or conclusion will follow. Now, one thing you should remember is to check whether the subject and predicate of the conclusions are in the same order, or whether the subject and predicate of the conclusions are in the reverse order. Subject and predicate are in the same order when the subject and predicate of the first conclusion is the same as the subject and predicate of the second conclusion. They are in the same order. The subject and predicate of the conclusions are in the reverse order, means that the subject of the first conclusion will be the predicate of the second conclusion, and the predicate of the first conclusion will be the subject of the second conclusion. Thus, the subject and predicate of the two conclusions are in reverse order. So, you have to remember to check whether the subject and predicate of the conclusions are in the same order or in the reverse order. Now, for complementary pairs, some not, and some no, it does not matter whether the subject and predicate are in the same order or in the reverse order. Either way, either or conclusion will follow. But for the complementary pair all, some not, either or conclusion will follow only if the subject and predicate are in the same order. If the subject and predicate of the conclusions are in reverse order, then either or conclusion does not follow for the complementary pair all, some not. Let's understand the meaning of basic diagram and possible diagram. A basic diagram represents the least possible situation for a given statement. To get least possible representation, the diagram should contain minimum overlapping. A possible diagram is any diagram other than the basic diagram for the given statement. For a statement, several possible diagrams are possible. but there should be no contradiction of the statement. That is, there should be no violation of the given statement while drawing the possible diagrams. Now let's understand what about basic and possible diagrams using an example. Look at these statements. Some walls are roads. All roads are floors. Now here, this figure is the basic diagram as it has minimum overlapping. These figures are the possible diagrams. Now, as you can see in this basic diagram, some walls are roads is represented by intersecting circles. So, this part shows that some walls are roads. Now all roads are floors. So all roads are inside floors. So this is the basic diagram for the given statements. Now look at this possible diagram. Now here roads are inside floors and floors are inside walls. So as you can see here, this part of the walls are roads. So some walls are roads. Now all roads are inside floors. So all roads are floors. So you can see that in this possible diagram, the statements are not violated. Now let's look at this possible diagram. Here, walls and roads are intersecting circles and these are inside floors. Now as you can see here, since there is an intersection here, it means that some walls are roads. And since roads are inside floors, this means that all roads are floors. So here also the statements are not contradicted. Let's look at this possible diagram. Here roads are inside walls and walls are inside floors. So here this part of the walls is roads. So some walls are roads. Now all roads are inside floors. So all roads are floors. Here also you can see that the statements are not violated. So while drawing possible diagrams, always see that there is no contradiction of the statements. Now, for a positive conclusion to follow, checking only the basic diagram is enough. If the conclusion is true in the basic diagram, then the positive conclusion follows. Now, for a negative conclusion or a possibility conclusion, you have to check both the basic diagram and the possible diagram. The conclusion follows only if it is true in the possible diagram. So, while for solving syllogism problem, you should be able to draw not just the basic diagrams but also the possible diagrams. Viewers, please go through this video till you have understood the concept. A thorough knowledge of the concept will help you in answering the questions correctly on this topic. Please do watch a video for basic concepts of definite conclusions. If you have liked this video, please like, subscribe and share this video. Thank you.